Hello everyone. Today we're talking about DLL hijacking and side loading. Now, while MITRE commonly quotes this under defense evasion, it can be also used for privilege escalation as well as persistence. It's a bit of a catch-all, and specifically why we're doing it is because it is one way that threat actors can evade traditional malware detections. We're doing this specifically by utilizing native binaries that are already on the disk, such as Microsoft's calculator.exe, in order to load malicious code and have our native signed Microsoft binaries perform malicious execution for us. And unfortunately, the only requirements for really doing this are getting the user to download and open a file. MITRE has its own documentation specifically for what groups and threat actors utilize DLL search order hijacking. And you'll notice a couple of common groups in here, as well as some common tools like Empire and Powersploit. But looking at a more recent example from 2022, we find Quackbot, which originally delivered several phishing emails to users for HTML files, which said, hey, this file can't be displayed correctly, use the local downloaded zip file. And it was, of course, password protected. If the user opened the zip file using the given password, it would mount an ISO image, usually under the E or F drive, which had a legitimate copy of Calculator, as well as a malicious copy of the normally benign Windows Codex.dll. Normally you can find Windows Codex.dll under the System32 folder. However, when looking at the command lines fired from these ISO image, they fired the local copy of Calculator, which before it checked the System32 folder, checked the local directory, in this case the mounted CD drive, for a quote unquote Windows Codex.dll. And this begs the question, how did the search order for these DLLs, instead of checking for the legitimate copy before the illegitimate copy, ever start to happen in the first place? Thankfully, Microsoft has really good documentation on Dynamic Link Library, or DLL, search order. Now, it really does depend whether it's a packaged application, unpackaged application, if you're running Windows 11, if you're running Windows 10, what version you're running, but I'm going to really oversimplify all of this. If an application gets called, it's going to check for these dynamic link libraries so it doesn't have to reinvent the wheel. All of these shared code repositories, is another way of thinking of it, are easier ways to run applications without having to write the same stuff over and over again. It's first going to check the API or the code itself, followed by checking if the DLL is already running under another process in memory, something that it can share resources on. Third, it's going to check the local directory of the application, followed by known good directories like System32. And it's specifically in this third step, the local library, that we plan to overwrite and hijack the DLL search order to run malicious code. So if threat actors can use Calculator, why don't we do the same? Let's use, in the top right here, SMB in order to perform a file transfer instead of a zip file. We will have a reverse TCP handler in Metasploit here on the top left. And on the bottom right, we have our targeted malicious DLL generated using a Meterpreter reverse TCP shell to our local host over port 4444, formatted as a DLL. And we can just overwrite it for fun. Now, going back to our device on Windows, let's perform this file transfer real quick. And let's copy Calculator. So, as you can see, this is a perfectly legitimate copy of Calculator. if we were to launch it, we can see in Process Monitor that it loads directly from the directory it's in first before it checks other directories. We see this where it says result name not found in all of these. So we can tell right off the bat that calculator is looking for 5 DLLs. It is looking for propsys.dll, urlmon, and a couple of others. But since we are creating a malicious copy of propsys.dll, we know that calculator will first check the local directory it's in before it checks system32. So, why don't we create a malicious copy of that DLL? And I'm just checking real quick. Okay, we did create a new version of it. We can see it is right there. And we can transfer it over real quick. And there's our DLL. Now, before we execute calculator again, you'll see we don't have a shell yet. However, once we load calculator, it will try and it will find this DLL, and it has multiple successes for finding the DLL in the local directory first. However, we don't see calculator popping up as we expect because it's firing a reverse shell right back to where we need it. And we're on the box. If you're trying this yourself, first create a local copy of whatever binary you're trying to target. Then create 3 filters inside of Process Monitor. First, add your process name as a contains field. Then add a second contains field containing .dll as the value. And finally, exclude specifically C Windows System32. What you're looking for is whenever you fire your binary, for it specifically to throw errors of name not found, just like these top results here. We can see, specifically when we launch calculator, it is looking for 6 different DLLs in the local directory before it starts checking C Windows System32. Technically, we could have created a malicious DLL that had any of these 6 names. I just chose propsys because it was top of the list. Now, there is a reason why DLL search order hijacking is classified as defense evasion. And that's because it is very difficult to detect without implementing custom detection rules. For instance, if we're looking at our Windows event log specifically for calculator, our first result actually looks quite promising. We see that calculator is spawning run DLL 32, which is exactly what we're looking for. However, it does not tell us anywhere in these events specifically what DLL was loaded. So, this is a dead end. Now, if we try modifying this, let's say instead of looking for a calculator, we look for events with run DLL 32, right? Maybe if we say, hey, specifically looking for creator process involving calculator. We can shorten this out even, just say, hey, any version of calculator. Not necessarily coming from a desktop directory, right? Even then, it still doesn't tell us what DLL was loaded. Because by default, without us enabling different logging capabilities, it does not by default record what DLLs are loaded. This is because run DLL loads hundreds, if not thousands of DLLs every single hour on every single device. Another dead end for us would be if we were to try looking through specifically our network logs, looking for our reverse shell connection coming back on port 4444. Even here, we still don't get quite enough information to tell us what's going on. We see that it's coming in an odd port, and this is definitely traffic that should be flagged, but it's not telling us what process is starting this connection. So, there are two options we can go for as far as detection and prevention of these attacks. First is a good EPP tool, endpoint protection program tool, such as CrowdStrike Falcon, Sentinel-1, Microsoft Defender for Endpoint, and many other capable EPP tools. This is in order to prevent the file from being written to disk in the first place. Additionally, we can enable additional security logging outside of traditional Windows security event logs in order to actually write and document what DLLs are being loaded by our run DLL. As always, I hope you learned something, and thank you for joining me.